Hey there everyone, in this video we're looking at factorising. So in another video called expanding brackets, we looked at going this way, so where we take the value that's in front of the brackets and we expand it and we get this answer. What we're looking at in this video is how do we take this and put brackets around. So factorise equals brackets back on. And then we're going to apply that law, like the distributive law, to do factorize our expressions. So thinking about that and applying it into a different context. The two things that I want you to remember in terms of vocab is remembering a multiple, which is here, and a factor. So a multiple is when you're counting up in that number. So 3, 6, 9, 12, 15, 18, they're all multiples of 3. So that's what we mean by that. And then a factor, remember factor sounds like fracture. So what can you divide a number by without it having any remainders? So if I have a look at 12, its factors are 2 and 6, 3 and 4, 1 and 12, and vice versa either way. Okay, so that's what we're looking for. They're the two things that are going to help us with factorizing. So here we go. Actually, I'll just sneak past that because this would be normally in a class. So what we're going to be looking for is highest common factors. So that's what we're looking for when we factorize. So those common factors are going to be the coefficients. They're the numbers at the front and the variables. So looking for those letters. So if we have a look here, 14FG and 21GH, we're looking for the highest common factor, both the numbers and the variables. So if we have a look at 14 here, I've got 1 and 14, 2 and 7. And then with 21, we got 1 and 21, 3 and 7. Now, come quicker at this, you won't have to break it down like this every time. But if we have a look, these are our common factors, 1, 1, 7 and 7. The thing, though, that we need to note is we're looking for the highest common factor. So 7 is greater than 1, so that's our HCF, equals 7. Now, if we have a look at our variables, F, G, G, and H, that means G is the same, so there's a G as well. So the highest common factor for these two terms is 7G. Okay, so because they were actually being multiplied together. So it's all multiplied. All right, let's have a look at actually applying this factor, finding these common factors in algebraic terms to factorize the following expressions. So here's a, start off with that one. So we've got 2x plus 6. So what we do is we start to look for a common factor. You can do that thing where I've just had the numbers 2 and 6 and identify the factors that way. So 1 and 2, 1 and 6, 2 and 3. So it's 2. You can do it this way. However, if your multiplication facts are pretty good, you might be able to do that with mentally, so you don't actually have to show this here. So as you just notice quickly that 2 is the highest common factor. So we would write 2 out the front. Now, there's a variable here, but there's no variable here, so that means that there's no variable that's a common factor. We would then put our brackets in. So we would look at it like this. 2x divided by 2 and 6 divided by 2. So 2x divided by 2 means that we are left with an x, and 6 divided by 2 means that we would be left with 3. So the factorized form of 2x plus 3 is 2 times bracket x plus 3. And if you're ever unsure, lo and behold, we can expand. So do your crab claws, 2x plus 6. Hey, look at that, they match. So that's a way to check by expanding if you are unsure. Okay, so with B, let's do that one. And what we have is 3a plus 12. So looking for a common factor, or highest common factor, is 3. And this one can be divided by 3, so you put that factor out the front. There is no common variable, so we start with our bracket. 3 divided by 3. Again, with this red pen, you do not need to do this. This is just me showing you how you can do it mentally as well as like the training wheels, so to speak. So while you learn how to do this, 3a divided by 3 gives us a, and then 12 divided by 3 gives us 4. So the factorized form is 3 times a plus 4. Right, and then C. So I'm going to do this now without that red annotation. So 5k minus 50 equals 5 is a common factor. Well, 5 is a prime number, first of all, so it only has 1 and 5. So 5 divided by 5 is, 1, so you've got a k, and 50 divided by 5 is 10. So that's your factorized form. Notice how I didn't do all this stuff here? You do not need to do this. This is a training wheel or a helping you understand and learn the process, okay? This is what we're looking for when we say show you're working to factorize something. The answer's, if the question's not given to you, write that down and then the answer as well. All right, let's have a look when there's a variable on both terms. So D, we have 10m minus 15n. 10 and 15. Now you might be like, oh, wait there's a couple of things going on here. Their common factor is 5, or highest common factor. So 10 divided by 5 is 2. Oh, sorry, and there's no common like terms between the variables. So m, and then plus 15 divided by 5 is 3, and now n. So there we have it, and then e. So this is where we would take the variable out to the front as well. So e is 16e plus 24e equals, the highest common factor for both those numbers is 8, and the e as well. So that would be 16, so it's 2 plus 3. Obviously we could do that as, you would still need to do that way. All right, got that right. And last one is F. So excuse me while it's a bit low, just move it up a bit. So F, a squared plus 8a. Now if you have a look, remember invisible maths, there is a 1 here. So 1 and 8, the highest common factor is 1. So we wouldn't write that out here, would we? Because again, that's that invisible maths. But the common variable is one of these a's. So that's a. What we need to have something here, and it's going to be a, because it's like a divided by a. So using your index laws, so a squared divided by a gives us 1, because it's 2 minus 1 equals 1. That way. And this would be 8, but no a, because it's been divided by a already using your index laws. All right, so when in doubt, apply those laws to your dividing when it comes to your factors. Okay, so that's how you factorize, applying the distributive law to factorize algebraic expressions. Okay, thanks a lot there. Bye.